Okay, let's take a look at one last example. Travis jumped off a diving board 20 meters high with a velocity of 2 meters per second squared. Write a quadratic model to represent this situation as a function of time. So we are going to use our negative 4.9 because we're dealing with meters. So the height is going to be negative 4.9 times t squared plus our velocity plus the initial height. Our y-intercept represents the height at 0 seconds that Travis began. So he's on the diving board and he starts 20 meters high. The vertex is going to be how high he reaches at a particular time. And our zeros is when Travis lands in the water. And of course, we're going to have one root that is irrelevant. We can't have negative time. So this root right here will tell us how long it takes for Travis to hit the water. Travis's initial height is 20 meters. So he starts at 20 meters here. The maximum height is going to be the output whenever we find how many seconds it takes to reach this height. So first of all, let's find how many seconds it takes to reach that maximum height. So negative b over 2 times a. And this is going to be a very quick amount of time. So we have negative 2 divided by negative 9.8. And I'm going to round to 0.2. So that's going to be 0.2 seconds is what it takes for him to jump from, he's on the diving board here to reach that maximum height, and then he's going to come down. So now we have to plug that in. And so let's plug it in for t. So it takes about 0.2 seconds to reach that maximum height. And then I'm just going to plug all this into the calculator using parentheses when needed. Don't forget your negative. And in 0.2 seconds, he is going from 20 feet to about 23, and I shouldn't say feet, I mean meters, 23.8 meters. How high, so what is a height that Travis will be in 2 seconds? So we're going to plug in 2 for time. So negative 4.9 times 2 seconds. And again, be very careful when you enter in your calculator. And in 2 seconds, he's going to be 4.4 meters above the water. How many seconds will it take Travis to reach the maximum height? And we just calculated that here, so we don't need to recalculate. So about 0.2 seconds, again, to go from where he initially started to the maximum height of right here in our problem. How many seconds will it take Travis to hit the water? So we're going to use quadratic to find this root here. We will have one that's negative, and that one will be irrelevant. And we're going to say t equals, so our quadratic formula, negative b plus or minus the square root. We have b squared minus 4 times our a value times our c value all over 2 times a. Let's clean this up. Negative 2 plus or minus, we're going to have 4, and then we have a negative times a negative, so that's plus. And now let's multiply those out. 4 times 4.9 times 20 gives us 392 over negative 9.8. We have negative 2 plus or minus, don't forget that, plus or minus, and then when we add those together, we get 396 over negative 9.8. So we're going to have, let's see, the square root of 396, and we're going to round, it's 19.8997 and so forth. So I'm going to say 19.9. So we're going to have negative 2 minus 19.9 over negative 9.8 and negative 2 plus 19.9 over negative 9.8. So go ahead and calculate both. So we have negative 2 minus 19.9 divided by negative 9.8. This gives us about 2.23469 and so on. I'm just going to say 2.2. That's seconds. And then this one is going to give us our negative answer. And we divide it by negative 9.8. That gives us a negative 1.8 about seconds. So again, this one is irrelevant. So it takes him about 2.2 seconds to hit the water. So this is our 2.2 seconds. It took about 0.2 seconds to get the maximum height. And then I think we answered another question in 2 seconds. So in 2 seconds, so we'll say about right here, this is the 2 seconds. We were about 4.4 meters. So about, we'll just say about right here. So again, when you're doing projectile motion, remember, the height depends on how long the object has been in the air. So your inputs are your seconds, your output is your height. And we're either going to be talking about meters or feet.